Welcome back to PromptGag, the only channel where we take ridiculous real-world metaphors and turn them into hardcore software engineering lessons. Today, we are exploring the legendary room for one more peanut paradigm, analyzing what actually happens when developers push memory buffers, queue capacities, and system boundary limits to the absolute brink of catastrophic collapse. We've all seen a squirrel stuff its cheeks with complete disregard for physical limits. But in production software systems, this exact greedy behavior manifests daily as aggressive micro-batching and dynamic array over-allocation. In this comprehensive guide, we will break down the underlying mathematical queue theories, inspect real code architecture, analyze stack traces from severe system crashes, and establish battle-tested best practices to keep your servers running smooth. To start with our core concepts, the Peanut protocol operates on the philosophy of maximum physical payload saturation, delaying F.
Second, instrument comprehensive observability metrics through Prometheus and Grafana dashboards, tracking cheek fill ratios, payload densities, and tail latencies so alerts fire before your heap explodes. By implementing proper rate limiters, circuit breakers, and graceful fault